Imagine a spacecraft on a daring mission. Its destination? The Sun. This is not science fiction, but the reality of the Parker Solar Probe. Launched in 2018, this incredible probe is on a journey to unlock the Sun's secrets. It will fly closer to the Sun than any mission before. The Parker Solar Probe is a marvel of engineering. It is built to withstand extreme heat and radiation. Its mission is to answer questions that have puzzled scientists for decades. Why is the Sun's atmosphere, the corona, hotter than its surface? What drives the solar wind, a stream of charged particles constantly flowing from the Sun? This mission is like sending a probe to a volcano. We want to study the volcano up close. We want to understand what makes it erupt. The Parker Solar Probe is our messenger to the Sun. It will beam back data, shedding light on the mysteries of our star. The Sun is the center of our solar system. It is the source of our light and heat. Understanding the Sun is crucial for understanding our place in the cosmos. The Parker Solar Probe will revolutionize our understanding of the Sun. It will pave the way for future explorations of our solar system and beyond. The Parker Solar Probe has several ambitious goals. It aims to unlock the mysteries of the Sun's atmosphere, the corona. The corona is a region of intense heat and activity. It is the source of the solar wind. Another key goal is to study the solar wind. The solar wind is a stream of charged particles that constantly flows from the Sun. It affects the entire solar system, including Earth. Understanding the solar wind is crucial for predicting space weather. The probe will also investigate the Sun's magnetic fields. These fields play a crucial role in many solar phenomena, including solar flares and coronal mass ejections. Understanding them is key to unraveling the Sun's complex behavior. The Parker Solar Probe is equipped with a suite of instruments. These instruments will measure the Sun's magnetic fields, plasma, and energetic particles. The data collected will help scientists answer fundamental questions about the Sun. The probe's mission is not just about understanding the Sun. It's also about understanding our place in the solar system. The Sun is the driving force behind space weather, which can impact Earth in various ways. By studying the Sun, we can better protect our planet from its sometimes harmful effects. The Parker Solar Probe carries 4 instrument suites. Each suite has a specific role in unraveling the Sun's mysteries. These tools are essential for making groundbreaking discoveries. The Fields Instrument Suite measures the Sun's electric and magnetic fields. These fields are responsible for the Sun's incredible energy. Understanding them is crucial to understanding the Sun's behavior. The SWEP Instrument Suite analyzes the solar wind. It measures the speed, density, and temperature of the charged particles flowing from the Sun. This information is crucial for understanding the solar wind's impact on Earth. The WHISPER instrument takes images of the Sun's corona. It captures the dynamic activity of the corona, including solar flares and coronal mass ejections. These images help scientists visualize the Sun's complex processes. The ISIS instrument suite measures the energy of particles in the solar wind. These particles can have a significant impact on Earth's atmosphere and technology. Understanding their energy is crucial for protecting our planet. These instruments work together to provide a comprehensive view of the Sun. They are like detectives, gathering clues to solve the mysteries of our star. The data they collect is helping scientists rewrite our understanding of the Sun. The Sun is not a quiet neighbor. It is a dynamic star that can impact Earth in various ways. The study of these impacts is known as space weather. Space weather refers to the conditions in space that can affect Earth and its technological systems. It is driven by the Sun's activity, including solar flares and coronal mass ejections. Solar flares are sudden bursts of energy from the Sun. Coronal mass ejections are massive eruptions of plasma and magnetic field from the Sun's corona. Both can disrupt radio communications, GPS systems, and power grids on Earth. The Parker Solar Probe is providing valuable data on the Sun's activity. This data helps scientists predict space weather events and mitigate their potential impact on Earth. By understanding the Sun's behavior, we can better protect our planet from its sometimes harmful effects. Section 5. A Legacy of Discovery. The Parker Solar Probe's Impact. The Parker Solar Probe is already making groundbreaking discoveries. It has provided unprecedented insights into the Sun's corona and solar wind. Its findings are challenging existing theories and paving the way for new ones. The probe has discovered that the sun's magnetic field is much more dynamic than previously thought. It has also observed rogue plasma waves in the solar wind, a phenomenon that was not expected. These discoveries are revolutionizing our understanding of the sun and its impact on the solar system. The data collected by the Parker Solar Probe is freely available to the scientific community. This open access policy is fostering collaboration and accelerating scientific progress. Scientists worldwide are using the probe's data to make new discoveries about the sun and its influence on our planet. The Parker Solar Probe's mission is ongoing. It will continue to orbit the sun, getting closer and closer with each pass. With each orbit, it will send back more data, further expanding our knowledge of the sun and its mysteries. The mission is expected to last until 2025, but its legacy will endure for decades to come. Section 6. The sun's energy source of life and challenge. The sun is a giant ball of burning gas. It's the ultimate source of energy for life on Earth. But this energy can also pose challenges. The Parker Solar Probe helps us understand both sides of this coin. Plants use sunlight to grow. We eat plants and animals that eat plants for energy. The sun's warmth drives our weather patterns. It's essential for life as we know it. But the sun also emits radiation. Some of this radiation is harmful. The Earth's atmosphere protects us from the worst of it. But solar flares can disrupt our technology. The Parker Solar Probe helps us predict these events. Understanding the sun's energy output helps us in many ways. It guides us in developing renewable energy sources. It helps us design spacecraft to withstand the harsh conditions of space. The Parker Solar Probe is a key player in this quest for knowledge. Section 7. Solar wind, a constant stream from the sun. The sun is constantly blowing a wind. Not the kind we feel on Earth, but a stream of charged particles. This is the solar wind. The Parker Solar Probe is giving us our closest look yet at this phenomenon. The solar wind travels at incredible speeds. It carries with it the sun's magnetic field. This magnetic field interacts with the Earth, creating beautiful auroras. But the solar wind can also be disruptive. It can cause problems with satellites and communication systems. Understanding how the solar wind works is essential for protecting our technology. The Parker Solar Probe's instruments measure the solar wind's speed, density, and temperature. This information helps scientists understand how the solar wind is generated and how it affects the solar system. Section 8. Unveiling the corona's secrets. A closer look. The sun's atmosphere has an outer layer called the corona. It's much hotter than the sun's surface, which is a mystery. The Parker Solar Probe is designed to solve this puzzle. The corona is only visible during a solar eclipse, or with special instruments like those on the Parker Solar Probe. It's a dynamic region with constantly changing magnetic fields. The coronal heating problem is one of the biggest mysteries in solar physics. Why is the corona so much hotter than the sun's surface? The Parker Solar Probe is gathering clues to solve this puzzle. By flying closer to the sun than any mission before, the Parker Solar Probe is able to directly sample the corona. This is providing unprecedented insights into its composition, temperature, and dynamics. Section 9. Protecting our technological world. The importance of space weather prediction. Our technological world is increasingly vulnerable to space weather. Solar storms can disrupt our communications, navigation systems, and power grids. The Parker Solar Probe is helping us improve space weather prediction. The probe's data is helping scientists understand the origin and behavior of solar storms. With this knowledge, we can develop better forecasting models. Early warning systems can give us time to prepare for solar storms. Power companies can adjust their grids. Satellite operators can put their spacecraft into safe mode. The Parker Solar Probe is a vital tool in our efforts to protect our technological infrastructure from the sun's sometimes harmful effects. Its discoveries are leading to more accurate space weather forecasts, which are essential for mitigating risks and ensuring the resilience of our technological systems. Section 10. Inspiring future explorers. The Parker Solar Probe's enduring legacy. The Parker Solar Probe is more than just a scientific mission. It's an inspiration. It shows us what we can achieve when we push the boundaries of exploration. Its legacy will inspire generations to come. The probe's daring journey to the sun has captured the imagination of people worldwide. It's a testament to human ingenuity and our thirst for knowledge. The mission is also inspiring the next generation of scientists and engineers. The discoveries made by the Parker Solar Probe will shape the future of space exploration. The Parker Solar Probe's enduring legacy will be its contribution to our understanding of the universe and our place within it. Its mission is a reminder that there is still much to explore and discover, and that the pursuit of knowledge is a journey worth taking.